Are you one of these people who left Web3 for AI? I hope not. But instead of choosing one way or the other, it's way smarter to combine them. Because this way, you can still leverage your investment in Web3 and ride the AI wave. All right, let's go. How are we going to combine AI with Web3? In Web3, there are many apps that deals with finance. That's what we call DeFi or decentralized finance. Could we combine AI with DeFi? The problem is that with DeFi, we need to be 100% correct. For example, one kind of DeFi app is decentralized exchanges or DEX, where two people can buy and sell tokens on the blockchain. So if a trader buys some token, he or she wants exactly the number of tokens that was agreed upon. So there are probably some use cases of AI in DeFi, but at first glance, it doesn't seem obvious. The other big category of apps in Web3 is NFTs. So you probably heard about these images that can cost a lot of money. Nowadays, it's not as popular as it used to be, but it's gonna come back at some point. And AI is very good to generate ideas and creative stuff. For example, it can write articles, generate talking points, titles, and create images. What if we use AI to generate the images of an NFT collection? Can you imagine how fast you could iterate and try different concepts for NFT collection? The NFT hype was insane in 2021, and I can't imagine how more insane it would have been with AI. I really love this idea, so let's try this. So which tool are we going to use? We're going to need to write some code, so we need to pick a programming language. There are many possibilities, but for blockchain, we have the most libraries that are written in JavaScript and Node.js, so we are going to pick Node.js. We are also going to need to use a code editor. There are also many choices for that, but I recommend to use VS Code. That's very popular, that's very easy to use for beginners. We will also need to use a tool to generate the images for our NFT, and the best option is the API of OpenAI. You don't need to know anything about AI. They made a very simple to use API that everybody can use. Once we generate these images with AI, we need to store them somewhere. So it's not really a good place to store these images on the blockchain because it is very expensive to store a lot of data on the blockchain. So instead, we are going to use a decentralized network that is called IPFS. So it's not a blockchain. You can see it as a sort of file system that is distributed a little bit like BitTorrent. Once you store an image there, it's going to be stored forever. Another thing that we need to choose is the blockchain where we will deploy our NFT. So the dominant blockchain in the blockchain ecosystem is Ethereum, but the problem of Ethereum is that it's very expensive to deploy anything there. So it's a way better option to choose a blockchain like Polygon, which is basically like a sort of secondary blockchain that is attached to the ecosystem of Ethereum, but it's much cheaper to send transactions there. And it still has all the tooling of the Ethereum ecosystem. And finally, we also need to use the API to access IPFS and the Polygon blockchain. There are many choices available, but we are going to pick a blockchain API which is called Starton. And the big benefit of Starton is that with one API, you can access both IPFS and the blockchain. And also it's able to process a lot of transactions very quickly, which is very useful in the case of NFT because during the minting process, we're gonna need to have a lot of throughput. So here's the whole process. There are three phases. First, we are going to generate the NFT images, then we're going to deploy the NFT smart contract, and finally, we're going to mint the NFT. So in the first phase, the generation of images, we're going to use OpenAI for that, and we are going to deploy the images on IPFS. After, we are going to deploy the smart contract of the NFT on the blockchain, and this smart contract is going to reference some metadata that is deployed on IPFS. And finally, for the minting phase, this is when the different tokens are created and sent to the different recipient, and each of these tokens is going to have a reference that is stored inside the blockchain, and this reference will point to metadata that is stored on IPFS, including the image of each token. So now we understand the whole process, and next we're going to start the coding. So I pushed my project on GitHub, so if you want to follow along, go to my GitHub repo and download the code. And if you're a newbie and you don't use Git yet, there is a download button that you can use on GitHub. Then on your laptop, you open the project with Visual Studio Code or any other code editor. And after, you are going to duplicate the env.example file into .env. So in general, in coding, we put our secret in .env. Everything that must never be shared with other people, such as API key. If you've never used API key before, these are basically secrets that you use to access services. These are basically like passwords that you use to access services. We have two API key, the one for Open API and the one for Starton. So for Open API, you will need to go to the website and create an account. This is separated from the account that you would use for ChatGPT. And after, you will need to take the paid subscription because the API is only accessible with the paid subscription. And just to be clear, this paid account is separate from ChatGPT Plus. So if you already have a paid account for ChatGPT Plus, you need to pay again. But don't panic, because if you want to follow this tutorial, it's not going to be very expensive. It's only 2 cents to generate one image. And after, you will be able to create an API key and you copy paste it into your .env file. And next, we need to create our API key for Starton. So go to the website of Starton, create an account. And this time they have a free tier, so no need to pay anything. And when you create an account in the dashboard, it will create a default project. So you go inside, and in your default project, you go in the developer menu, you create an API key, and you paste it in the .env file. So now we have our secret defined. The next step is to define the configuration file. So you're gonna open this file in your code editor, and we need to add some info. We need to create an Ethereum address. This will be used to sign a transaction when we deploy our NFT and when we mint it. So it's possible to use your own address, but for this tutorial, we're gonna use a cool feature of Starton which allow you to create addresses in the dashboard. So in your project, you go in the wallet menu, you click here, and after you choose this option, and it will create a wallet, and the private key will be stored on AWS. So you don't need to know anything about AWS, but the point is that the private key is stored on the cloud. So even though AWS is pretty trustworthy, that still poses a security threat. As we say, not your key, not your crypto. So what we do here is good for a tutorial, but in production, you don't want to do this. So after, you go back to your code editor, you open the configuration file, and we are going to paste our address here and here. For the network, we're going to use the testnet of Polygon. If you never heard of Polygon, that's what we call a layer 2 scaling solution. It's basically a secondary blockchain that is attached to Ethereum and that offer much cheaper transaction costs compared to Ethereum. And in this case, we're actually not even using Polygon, but we're using a testnet, which means we don't need to pay any money to deploy smart contract on this blockchain. This is a safe playground that you can use for development. And in here, another thing that you can change is the prompt that we're going to use to generate the image with the OpenAI API. And you can also change the size of images. All right, so now we have finished our configuration, and the next step is to generate images with the OpenAI API and upload these images to IPFS. So in your code editor, you are going to open this file, and here we're going to import some libraries that we're going to use. So Axios is to make HTTP requests. Form data, this is going to be useful to upload our image to Starton, and we're also going to import some secret and configuration. And after that, we're going to create a JavaScript object to communicate with the OpenAI API. Next, we're going to define a function to generate our images. So here, the important part is the API call that we do to OpenAI. So they have a specific endpoint for image generation /images/generations. And you need to specify a couple of parameters. And the most important is the prompt that tell OpenAI what to generate and the size of the image. And in the response, we're going to get a URL that's where the image is located. So very simple function. So here we have a little problem because even though we do have our image, this is on a URL, but to upload it to IPFS, we need to have it in a binary format. So we need to fetch the image from this URL and convert it into an in-memory binary format. I know it sounds pretty complex, but don't worry, it's gonna be short. So we're gonna do this in this other function. So first we get the image from the URL of OpenAI, and then we're gonna convert it to this binary format by using the buffer module of Node.js, and that's it. And after we can use this to upload the image to IPFS. You see, that wasn't too bad. So next step, we're gonna upload this to IPFS. And for that, we define another function. We pass it the buffer that we defined before. And here we create a new instance of form data. So I'm not gonna get into the detail, but basically this is used whenever you want to upload images. And the important part is when we add this image buffer into our form data, line 45. And after that, we're gonna upload the image to IPFS by using the Starton API, and we pass it the form data object that we just created before. And in return, we're gonna have what we call a CID. So that's a unique identifier that allows to locate our image on IPFS. Very cool. So now the image that we generated with OpenAI is deployed on a decentralized network of IPFS. And next, we need to deploy the metadata to IPFS. So the metadata is a JSON document that describes some meta information about our NFT, including the image. So for that, we define another function. We define our JSON objects. We want to specify the prompt that we use to generate the image, then the URL to the image on IPFS and the description. And after that, we upload this JSON object on IPFS by using the API of Starton once again. And once again, we get a unique identifier to locate this JSON object on IPFS. All right, so we're almost done for the image generation. So now we need to put everything together. And so for that, we create another function and we're gonna do the whole process. So first we generate the image, then we transfer the image into a buffer, then we upload the image to IPFS, then we upload the metadata on IPFS, and that's it. And after we execute the function, all right, so now this is the moment you've been waiting for. So we're gonna execute our function. So let's go to our terminal and we execute this script. And here we can see a bunch of information. And the most important is the unique identifier of the image and of the metadata. So let's check out our image. So copy paste this, and in your browser, you're gonna append this identifier to this URL and you will be able to see the image. Pretty cool. And you can also see your JSON object with the other unique identifier. So everything works great. And what is really fun here is to try all sort of prompts and you see what kind of images you get. So at first I tried prompts with pictures of humans, but I got terrible results. I got hands with 7 fingers. I got weird facial expressions. So OpenAI has a lot of progress to do, but then I thought, maybe it will work better with more abstract things or things that are well formatted, well defined, like pixel art. So that's how I came up with the idea of doing pixel art for the prompt. Another important thing with the API of OpenAI is the price of the API, because it's not a fixed subscription. You pay per usage, which I don't like because you don't know how much you will pay, like for AWS, but I calculated how much it costs per image and it's really not much. It's 2 cents per image. So if you generate 10,000 NFT, it would be a total of $200. So it's very cheap. All right, so now we know how to generate our images, and the next step is to deploy the smart contract of the NFT. So for that, in your code editor, you're gonna open this file. So first we import the required library and a configuration. And next we're gonna upload the contract level metadata to IPFS. So I know this is already confusing because we've already uploaded metadata before, but that was the metadata which is attached to each individual token of the NFT. But there is also some metadata that is attached to the whole collection of the NFT. And this is what we're going to define now. So in our code editor, we're gonna define this function and we're gonna pass the unique identifier of a specific image that we deploy on IPFS before. Then we define a JSON object with the metadata of this NFT collection. And after we upload the JSON object to IPFS by using Starton. And once again, we get the unique identifier in return. All right, so finally, we are ready to deploy our smart contract to the blockchain. So we define another function and we're gonna pass it the unique identifier that we just got from IPFS. And here to deploy a smart contract, we're going to use once again the API of Starton. This is another endpoint. So we define a couple of information, the network where we want to deploy the contract, who's going to sign this transaction. And we're also going to specify which smart contract template that we want to use. So we don't even need to provide the code of the NFT. Starton has a couple of templates for you. And behind the hood, they use the OpenZeppelin library to create that template, which is the most used Solidity library for NFT. And we also pass the unique identifier of the metadata, and this is going to be stored on the blockchain. All right, so now we need to create a function that put the whole process together. So we define this function here. First, we create the metadata. Then we deploy the smart contract. We pass the metadata as argument, and that's it. And so just below line 56, we're going to pass the CID of an image that we already deployed on IPFS. So just to make it easy, we can pass the CID of the image that we already generated. But in the real NFT collection, this will be actually a different image that represents the whole NFT collection and not a specific token. So now we can run this in our terminal, and we get the address of the contract as well as the transaction hash. And we can verify that this was actually deployed to the blockchain. And for that, we use Polygon Scan, which is what we call a blockchain explorer that allow you to inspect what's happening in the blockchain. And here, if we copy paste that transaction hash, we can see that the transaction was mined, which means that this was added permanently to the blockchain. And so here there is a very important detail to notice. For each transaction, we had to spend some testnet matic, which is the built-in currency for the testnet of Polygon. But where did this token came from? Because we didn't buy any. But when we created our address on Starton, Starton automatically sent some testnet matic to this address so that we can send transactions easily. And that's a very nice feature of Starton. It's very useful because the alternative is to use what we call a faucet. Faucet is a tool that people use to get some free testnet matic or for any other testnet that you use. And the problem with faucets is that they are very unreliable. So we save a lot of time and hassle by having this testnet matic directly. Next, we just have one step left, which is the minting process. The NFT smart contract is deployed on the blockchain, but we haven't minted any token yet. Minting is when we create all the individual tokens of an NFT collection and we send them to the specific recipient. So let's do this. So in your code editor, you open this file for the minting process. So first, as usual, we import the required library and configuration. And after we're going to create a function to do the minting, it's going to receive a couple of arguments. First, the address of the smart contract that we just deployed. Then it's going to receive an array of metadata CID. So this is the metadata that we uploaded to IPFS in step 1. And finally, a timeout in millisecond. And we're going to do this to simulate a real minting process where a lot of people will mint their NFT in a short period of time. So inside the function, we're going to loop through the array of metadata. So every iteration represents the minting of one token. And in each iteration, we're going to call the mint function of our smart contract. So line 6, we specify the address of the contract. Line 7, the function of the contract. And line 12, the address that is going to sign this transaction. And after, we're going to print some detail about the transaction. Finally, line 23, very important. We are going to wait between each iteration of this loop, and that's to simulate a real minting process. And so after, we are going to call this function. So here you need to replace it by the address of the smart contract that you just deployed. And in the array, you're going to pass the metadata that you generated in step 1. So here you can mint as many tokens as you want. So here I generated another image so that we have at least 2 to generate. Finally, the timeout between each minting is going to be 200 milliseconds. Okay, so this is finally the moment of truth. We are ready to launch the minting process. Let's go back to the terminal. Let's execute this. I hope this is going to work. And yes! it works. And once again, we can check that by copy pasting the transaction hash into Polygon scan. We make sure that the transaction was mined without problem. So on Polygon scan, we can see how much money we spent for minting one NFT. And if you convert this to dollar, it's $0.001. So it's very low. So if you mint 10,000 NFT, it's going to be $10 total. So that's really cheap. So in this video, we use a blockchain API called Starton. And what makes Starton so unique is that it's able to process a lot of transactions in a short amount of time, which is especially useful for minting NFT. One cool thing you can do if you mint NFT is to do meta transaction, which means that you pay for the transaction of your user. So that means that you're gonna need to have a backend for that. You're gonna send all the transactions yourself. But if you send a lot of transactions at the same time, if you don't use any API at all, you're gonna have all sort of problem with the ordering of the transaction. You're gonna overpay for gas. And so Starton really make things easier. And in general, Starton is very useful if you are building a backend application that does stuff on the blockchain. So next, if you want to build some really cool stuff with Web3, create a free account on Starton and experiment all the things that you can do with it. That's it for this video. Thanks for watching. See you next time.